In one of our earlier videos, we had a look at errors in measurement. In this video, I want to have a look at how those errors in measurement can affect our calculations. So if there is an error in the measurement, it can cause further errors when we use it in calculations of area, volume, or surface area. So our final answer of any calculation is only ever going to be as accurate as the least accurate measurement that we've used in the calculation. So if our least accurate answer was accurate to two significant figures, then our final answer is only going to be accurate to two significant figures as well. So let's have a look at an example of what this looks like. So our question says, Amy is going to paint a feature wall in her bedroom. She measures the wall to be 3.8 metres by 2.4 metres. So before we even see what the question is, if we look at these two measurements, 3.8 and 2.4, thinking back to what we did earlier with errors in measurement, our absolute error for both of those would be plus or minus 0.05 metres. So our true measurements, the actual length and height of the wall, could have been 0.05 metres either side of these measurements, and Amy still would have rounded to those. Right, so now let's have a look at what our questions are asking us. So part A of our question asks us, what is the smallest possible area of the wall? So the length of the wall was measured to be 3.8 metres. The smallest measurement that could have actually been, the smallest true measurement, would have been 3.75. So that's subtracting that 0.05 metres. And the smallest height would have been 2.35. So the smallest possible area of the wall would have been the smallest possible length times the smallest possible height, which would have come out to give us 8.8125 metres squared. Part B of the question asks us what is the largest possible area of the wall. So it's a similar sort of calculation. If this length was measured to be 3.8, the largest possible measurement it could have been was 3.85, and the largest the height could have been would have been 2.45. So at each of these measurements, we've added that 0.05. So the largest possible area would be those two measurements multiplied together, which would give us 9.4325 metres squared. So the true area of our wall is somewhere between that 8.8125 metres and the 9.4325 metres. So one more part to our question. So part C says, calculate the area of the wall correct to an appropriate number of significant figures. So we're going to use the measurements that Amy took, the 3.8 and the 2.4, to figure out the area. So we'll write 3.8 times 2.4, which will come out to give us 9.12. But we know that it's not going to be accurate to two decimal places. If we look at the measurements that Amy's taken, the 3.8 and 2.4, if we look at significant figures, they're both only to two significant figures. Our answer that we've got is three significant figures because we start counting at that 9. So what we said on that first slide was it's only going to be as accurate as our least accurate measurement. So our answer is only accurate to two significant figures as well. So we're going to round that to 9.1 metres squared to 2 sig fig. Right, so that's one example of how errors in measurement can affect the errors in our calculations.